Institutions face a crushing volume of data. To survive, they feed this chaos into automated decision engines, forcing information into a rigid, actionable grid. This image of the Pentagon represents the ultimate high-stakes environment. Here, Palantir's platforms, Foundry, AIP, and Maven, are the absolute standard for managing data. The industry operates on a dangerous assumption. Systems engineers typically measure AI safety by looking at access controls, versioning, and post-action audit logs. If the system tracks who clicked the button, it is considered secure. Applied meta-theoretical models, specifically the Bridge 360 framework, expose these procedural checklists as a catastrophic structural blind spot. Logging who has the clearance to execute a command does absolutely nothing to verify whether the logic behind that command is actually true or safe. Look at this workflow diagram showing Palantir's superpower, filtering noisy data into a clean ontology, linking a target entity directly to a strike. This establishes operational closure, creating executable metaphysics. An unproven map dictates real-world actions, trusted simply because it's computational and backed by massive datasets. Converting a data-rich map into absolute truth without pre-action limits guarantees systemic fragility. Every ontology is a compression of reality. To categorize the world, a system must inherently exclude context, nuance, and edge cases. As we look closely at mathematician Kurt Gödel, we are reminded of a hard limit in formal logic. Gödel's incompleteness theorem, alongside Turing's limits on computation, proves that no rule system can capture and certify all truths from inside itself. No finite computational framework achieves total, flawless closure over reality. The unclassified, messy reality excluded by the model does not vanish. It leaks out of the system in the form of institutional errors, forced classifications, and false positives. We see this play out here in an automated feedback loop. A false positive triggers a machine-speed action, which then writes back to the database as confirmed truth. The Bridge 360 framework defines this exponentially compounding error as an entropic blowout. Operationalizing an AI ontology without managing its inherent uncertainty does not resolve chaos. It weaponizes that uncertainty at scale. This military operations center relies heavily on an AI-enabled targeting stack driven by Palantir's Maven software. The stakes for getting the ontology right here are lethal. In the case of the Minab girls' school strike in Iran, U.S. investigators suspect the AI targeting package relied on outdated data. By the standard metrics of platform governance, the system likely functioned perfectly. Access was granted to the right personnel. A human reviewed the queue, and an audit log securely recorded the event. But watch what happens on this targeting interface. The photo providing the target evidence has a glowing red metadata tag, proving it is 2 years old. Post-action visibility did nothing to stop the execution based on this stale data. The system lacked what the Bridge 360 model calls a process policy state, or PPS, signature. There was no binding freshness requirement threshold to automatically halt the workflow when the data aged out. A system can be highly auditable after the fact, yet structurally useless as a pre-execution safety instrument if it cannot halt bad data. The Bridge 360 Metatheory model provides a structural fix. It installs a rigorous governance spine that evaluates the data before any action is taken. In this updated workflow, we insert a massive 5-layer security gate between the ontology and the final action. This is the admissibility spine. Layer 1 is the caveat vector. The AI must declare its assumptions up front, explicitly admitting if an image resolution is too low to confirm civilian absence. Layer 2 enforces entropy budgets and leakage accounting. The system must calculate exactly who bears the cost of a false positive and place a hard cap on allowable harm. Layer 3 is the weak convergence gate. High-stakes actions require confirmation from independent external methods. The platform's internal logic is not enough. Layer 4 establishes a rollback protocol. This enforced tripwire would have automatically halted the Minab strike the second source sufficiency or freshness thresholds were breached. An AI ontology must never be granted sovereign authority. It must prove its epistemic admissibility at every step before it is allowed to execute. The core engineering misconception conflates platform governance with epistemic governance. This comparison illustrates the difference. On the left, Palantir's operational focus channels data into a sharp, frictionless spear point of immediate execution. On the right, The Bridge 360 workflow applies necessary friction. It contains that same spear point within strict, measured brackets to prevent irreversible damage. Palantir is not the opposite of Bridge 360. It is the raw operational substrate that Bridge 360's rules are designed to audit and control. Speed and operational execution without epistemic containment is not efficiency, it is guaranteed systemic fragility. Data scientists and military policymakers face an intractable deluge of high-stakes information every day. As this split-screen graphic shows, surviving entropy requires discarding the assumption that computationally derived ontologies represent truth. Instead, we must accept that the pressures and limits of entropy are universal givens. Looking at Palantir's CEO Alex Karp, we acknowledge the incredible engineering prowess of these systems. But that massive power demands that their outputs be treated as provisional and inherently flawed. An audit log is an autopsy. It is not a guardrail. The sequence of operations must change. Do not operationalize first and govern afterward. You must govern the admissibility of the ontology before it is ever allowed to act.